logs. And what I compare logs to is square roots, because you know how to do square roots, and we know some square roots, and I sort of talked about this a bit last class. What's the square root of 0? Square root of 1, square root of 4, square root of 16. We know those. 0, 1, 2, oh, I missed 9. That's okay. 4. I didn't mean to miss one, but there it is. Logs are similar. Square roots are what? 2 squared equals 4. So that's why the answer is 2. 4 squared equals 16. So that's why the answer is 4. It's what number times itself, or squared, gives you whatever's under the bracket. That's what a square root is. So if I put 121, and maybe you know the answer, and maybe you don't. But if you didn't know the answer, what you would say is there 2 numbers that multiply together and give me 121? And it's 11, right? So this is 11. But you may or may not know the answer, but that's how you would figure it out. You have to say, okay, what 2 numbers? On a calculator, there's a button, and it will tell you what 2 numbers. And we talked about how to estimate. If you had to guess what the 2 numbers were, without a calculator, say I wanted it more accurate than our just guessing. If I said 118. So if we had this one, we would say, okay, well, the square root of 100 is 10, and the square root of 121 is 11, so this is between them. And which one's it closer to? It's closer to 11, so we could guess what? Let's make a squiggly equals. 10 point, what do we want to guess first? 7? Now, what if we want to check if that were right? Not using the square root button, because in your head you don't have square root. I'm going to use a calculator to make it quicker. But you could do 10.7 times 10.7, you know, multiply that out, and so on. Let's just get the answer. So 10.7. And I'm going to hit squared, but you could do times 10.7. No, I didn't hit squared. Whoops. 114. So were we right? No, what do we have to do? Go up. So then you could say, okay, what about 10.8 times 10.8? Whoops. 116. So 10.7 and 10.8 was 116. What was 10.7? 114. And what do we want? 118. We have to go higher. 10.9. I get 118.81. So we would have guessed a little off. That's a little closer. What would we have to do if we wanted it to be more exact? What would we have to do? We'd have to go in between these two. If you wanted to go in between 10.8 and 10.9, stick a 0 on the end. So that's 80 and that's 90. So what would be in between? Say 85, right? If you can't figure out 2 numbers between something, you can stick a 0 on the end, then you can see it better. So 10.85 would be in between. 10.85. Is that closer or further than the last one? It's closer, because this is only 0.3 away from 118. And the other one was like 9 away, 0.9 away. So that's actually a little closer, but you could keep doing that. Okay, so that would be how you would estimate. Now, that is what a square root is. And what's a cube root? Same thing, but if we were going to guess what a cube root was, we have to multiply like 10.8 times 10.8 times 10.8. Right, the 3 numbers that multiply is a cube root. A 5th root, we'd have to find 5 numbers that multiply to give it. Okay, so that's a square root. What is a log? So a log, I said, is power. So let's look at, like the square root, that's 2 numbers that multiply. Let's do log base 2, okay? So a log base 2 is this. Instead of squared, which is what a square root is, we're doing powers. So powers of 2, let's write them out. 2, 4, 8, remember 8 times 2, 16. These are the logs we know. 16 times 2, 32, 64, and so on. So, what do you think the number before that is? Any ideas? Well, this is 2 to the 1, this is 2 squared, this is 2 cubed, this is 2 to the 4. Yeah, good. The one before is 2 to the 0. What's that equal to? 1. So this is where they start with logs. Square roots start at 0. You can plug a 0 into a square root. You cannot plug a 0 into a log. The domain you can plug in anything bigger than 1, even 0.1, or bigger than 0, even like 0.1. You can plug in decimals too, but they just don't work out nice, just like a square root. They don't work out nice. But if you put any of these numbers in, they'll work out nice. Anything in between, you'd have to guess or use a calculator, just like with a square root. This is just saying the values that we can plug into this have to be positive, just like a square root. The only difference is that you can't plug a 0 into log, and you can plug a 0 into square root. Otherwise, it's the same. It has to be positive under the square root. It has to be positive to plug into a log. Okay? So they're identical that way. Just the answers are a little different. So log base 2, we put a little 2 that's like at the bottom, at the bottom of the G. Okay, so that's a little base. Log base 2 of 2 cubed is equal to 3. Log base 2 of 8, you'd say, is 8 a power of 2? Say, yeah, that's 3, so that's the answer. It's saying, how many 2's multiply to give 8? So if it's a log base 2, you're saying, how many 2's times by themselves, 2 times 2 times 2, gives us 8. That's what a log is. So you say, 2 to what power equals 8? That's the question. How many 2's multiply together to give 8? And the answer is 3. That's how a log works. Okay, does that make sense? So the ones that work nice are the ones that are a power of 2. Otherwise, you'd have to guess. It's between this and this. So if I said log base 2 of 64, what would we say? Is 64 some power of 2? So it is. How many 2's give us 64? 6. So what's the answer? 6. That's it. Nope. Nope. Just like, so she's asking, do we have to actually show this 2 to the 6? No. Just like a square root, what's the answer? 4. You don't write 4 squared equals 4, but that's what you're doing. Okay? So you don't have to write it, but you can. That's all a log is. Logs are not hard. They're actually, if it's a 2, it's telling you what base it has to be. So if I put log base 10 of 1,000, what's the question you say to yourself? How many 10's, because this is a base 10, multiply to give 1,000. How many? 10 times 10 times 3. So the answer is 3. That's it. Do you understand? So you need to know your powers because you can't use a calculator to multiply them, and you don't want to sit there and say 3 times 3 times 3. So if you know the powers, you can write them out and count. That's 1 power, 2, 3, 4, 5. Question?
If you were to write it out, like in words, it goes log base argument is exponent A.
If you were to write this out in words,
Yeah.
like how do I read that? This is log base 10 of 10 cubed. Is that what you mean, or no?
I'm trying not to confuse anybody when I ask you, but is 10 the argument considered the argument?
Yeah.
So
So like,
log
square
base.
root, whatever's under the square root's the argument.
Okay.
It's like what you plug into the square root. Yeah, the argument is this whole thing, 10 cubed. Yeah, that's called the argument. The argument is what you plug into a function. So if the function was square root, whatever you plug into it's called the argument. So the argument is 10 cubed. Okay, so let's just write a little list of some logs. Okay, do you see I wrote a little list of square roots here? Let's do the same thing with a few logs. So just to show you how they work. So if we had log base 2. So first of all, log base 2 of 1. Times 2, 32. Okay, and we could keep going. What are the answers to these? Yeah, what's 1? So I had the powers here, and I asked you what came before 2 to the 1, and it's 2 to the 0. So what's log of 1? 0. That's because I usually write down this second part, but this is 2 to the 0. Kind of the same color. There we go. So that's equal to 0. Any log of 1 equals 0. That's just, because that would be the 0 power. What would this one be? 2 squared. Oh, I missed one. I meant to go in order. 2 cubed, 3. 2 to the 4, 2 to the 5. They work out nice. And what, I'm missing the 1. What would the 1 be? Log base 2 of 2 is 1. Right, I don't know. I skipped that by mistake. So, what if I had log base 2 of 100? So, is 100, can we multiply a bunch of 2's together and get 100? That's your first question. No. 100 is 2 times 50, but 50 is not a bunch of 2's. 2 times 25, but this is 5 times 5. These are not all 2's. Right? The factors have to be all 2's for that to work, and it doesn't. So how would we do a guess, just like we do guesses with square roots? What 2 is it in between? That's what we would say. So, so 32, what comes next after 32? That's 2 to the 5, 64, 128. So what's it between? 6 and 7. So the answer is between 6 and 7. So this is between 2 to the 6 and between 2 to the 7. Which one's it closer to? So this is 64 and this is 128. Yeah, this is about 30 away. This is about 40 away. I'd say a little closer to that. So I would take a guess maybe that it's 6.6. I don't know. Right? But we're in between, and in between two numbers is all you need to get. Because what do we do with it? We draw it on a graph, and think about if you were drawing 6 tick marks up and 7, do you need to have it exact? 6.6? No, you just stick it in between 6 and 7 on the graph. Right? That's all you ever use them for. So you just need to be able to estimate square roots, cube roots, and stuff in between two numbers. So let me show you how to get it on a calculator, though. Okay, so on a calculator, there's a rule that's called change of base. Okay, so if we wanted the exact value, because there's no square root button for a log, for every log, there is for a square root. Like there's a square root button on the calculator. I don't know if you can see it. That's right there, square root button. And then above this button is all the other roots. It says X root. You can't see it, it's in orange, but it's there. I can put a 5th root in my calculator, a 10th root, a 9th root, whatever root I want, but you can't do that for logs. There is a log button on a calculator, right here, see it? But that's only base 10. They don't put any other base there, just base 10. So you have to be able to change the base, that's why it's called change of base rule, change the base to base 10 to be able to put it on your calculator. And the rule's actually really easy. If this is an A and this is a B, then this is log A divided by log B. So if we wanted to figure out log base 2 of 100, what I plug into the calculator is log of 100 divided by log of 2. So let's do it. So I'm going to hit log of 100 divided by log 2. 6.6. We were right on. 6 point, you can't even see it, but it says 6.64. There it is. So we guessed pretty good guess. Okay, but that's how you do it. So you can do it on a calculator, and in Math 1013, which is the second calculus, there's word problems that use these, and the homework, you do need to use a calculator to get the exact answer. So they expect you to do that. They just don't make you work it out on a test. You just leave it as the log on the test because they don't have a calculator for tests, but on homework you would have to know that change of base formula. I remember it because the A looks like it's on top of the B. Do you see that? A is on top of the B. So the other button, there is a ln button here, LN, which I'll talk about in a minute. Do you see that right beside the log? You can actually do that for that too. You can hit ln of 100 divided by ln of 2, and it gives you the exact same answer. So either of those buttons actually work. But there's no log of any other base on there. Okay, so that's how it works. Let's put another base. So log base 3, and let's just guess a random one. So let's say 81. So what do you ask yourself? You say that the base is 3, so I need 3 times 3 times 3 times 3 so many times to get 81. I'm self-conscious now of I keep pointing with my middle finger. The kids watch one of my videos. They said, "Are you always this boring?" I said, "Yes, I would not watch all 40 minutes." They said, "But you give the class the finger all the time." And I said, "Well, right?" I said, "Well, I'm holding my pen. I can't, like, put the pen down and point with that finger." So now every time I do it, I think of them saying that I'm giving you guys the finger. So, yeah, so what you ask yourself is 81, 3 times 3 times 3 times, like, how many 3s is it? You could use this little factor theorem to figure it out. That's 9 times 9. 9 is 3 times 3. That's 4 3s. So the answer is 4. Make sense? Did anyone know logs were this easy? what they do in school, I think that makes it seem like it's something weird, is they give you an inverse relationship, and they say, if you have a log, see if you remember this, and you're trying to solve for x, you write down 3 to the power x equals 81, and then you work that out. Which is fine, because that is what you're doing. You're saying 3 to what power equals 81? But then you're memorizing like a step instead of actually just thinking about what you're doing. And I think that makes people sort of confused. These two relationships are the same, because we're trying to say 3 to what power equals 81? Well, x would have to be 4. So that's 4. Okay? I just don't do it that way because I don't find that as intuitive. What if we had this? Now it has to be a power. So what power does it have to be? A 4, yeah. So we're looking for powers of 4. 4 times 4 times 4. But 16's on the bottom. So what do you think we would do here? 16 is 4 squared. This is not equal to 2. It would be minus 2, because this is log base 4. If we bring that up to the top, we'd have 4 to the minus 2. And that's equal to minus 2. Now, what I sort of say to people is if you can get these to match, cancel it out and the exponent's the answer. Does that make sense? So if you can get these to match, then you cancel it out and that's the answer. So, note, log base 10 is written as log with no base. So the base isn't shown. What square root do we not show what root it is? 2. Square root with a 2 here is written as just a square root symbol. Right? We don't put the 2. It's not wrong to put the 2. It's just not the standard way we do it. But every other root has to have the 2, has to have the number there. With logs, it's 10. 10 is the one that they don't show the base. So if you just see log by itself, the base is 10. You could write a 10 in there if you wanted to. And then the other one is log base e. Remember, e was about 2.71. This is written as ln. I call it ln, like a lawn. Right? That's how I pronounce it. All right. So you can say ln if you want. But so if you see ln, the ln, you could rewrite it as log base e, and that's okay. They mean the same thing. Okay, so let's go to my notes and see what I wanted to do. Okay, so solving log equations, that's what we want to look at. So last class, we solved exponential equations. So let's write one down, like this. And do you remember the technique I said? It's kind of the same thing we're doing. We're saying, can 8 be written as a base 2? And what would it be? 2 to the 3, so x equals 3. So we made the bases the same. And compare the exponents. That was what we did. Now, what we didn't do was ones that don't work. So 8 can be written as a base 2, but 7 can't. So that's where we need to use logs. Okay? So let me show you the equivalent with like a cube root, for example. So if I had x cubed equals 5. How do you solve for x? What do you do to both sides to get rid of the cube? Cube root. So we take the cube root of both sides, and whatever that's equal to is the answer. 3, 5. So that doesn't work out nice, but that would be the answer, whatever that is. You could either estimate it or put it in the calculator and get the answer. So what we do to both sides is what's going to cancel out the cube. We did the opposite, it's called the inverse, because that 3 and that cube root will cancel. We do the same thing here when we've got that, but the opposite is a log. So what's going to make the two cancel? Now remember, we just did these. If I put log base 2 of 2 to the 7, what's the answer? It doesn't even matter what 2 to the 7 is. When these match, the answer is the exponent. It's 7. So just like a cube root of a cube, base 2 of a 2 cancel out and the answer is the exponent. So what would log base 2 of 2 to the x be? X. Log base 3 of 3 to the x squared. They match, so it's equal to x squared. They cancel each other out. So if we have an equation like this, 2 to the x equals 7. So we notice that 7 is not a power of 2. So it can't be written as 2 cubed or something. We can't do it because it's not a power of 2. We take the log of both sides. And what log are we going to use? What log is going to cancel out a base of 2? 2. So log base 2 of both sides. So we would write log base 2 of 2 to the x equals log base 2 of 7. So what's log base 2 of 2 to the x? X. And the answer is log base 2 of 7. Now, since we're not using a calculator, we would just leave that. We're not graphing logs, so you don't even have to estimate. If we were graphing it, we would say, okay, well, it's between 2 and 3, so let's say 2.7 or something, and you would estimate it. But we don't even need to do that. If we did want an exact answer, we could put it on the calculator, or we could do our guess, right? And how would we put that on the calculator? Yeah, log 7 divided by log 2 will give us an answer. Okay, so if on the final exam, for instance, I said estimate the value of this, you couldn't do that. You would have to figure out what 2 it's in between and do it that way. Okay, so that's how to solve exponentials that don't work nice. You take the log of both sides. So we'll do a couple of those. So the question is solve for x. So some of these will work and some of them won't. So there's number 1. Number 2. Probably off the page, but okay. So my question, don't worry about the technique. So we've got two ways to do it. Either you can make the base the same on both sides, you compare the exponent, or you can't and you have to take the log of both sides. Those are the two methods. That's it. Doesn't matter how complicated I make it, you first try to make the base the same, and if it doesn't work, you take the log of both sides. Can you make the base the same for the number 1? What's your guess, even if you don't know how to do it? Yes or no? Yes. Because, why? We've got a 5, and 25 is 5 squared, right? So we can make both sides 5 to some power, let's say. And then we would compare the exponents. So once we get a big 5 on both sides, whatever is up there for the exponent, we set them equal, and then that's our new equation to solve. So that's technique 1. So 25 is what? 5 squared. What about the 2x that's already there? Put in a bracket. When it's on the bottom, that's a 1. We move it up to the top. So now the base is the same. We compare the exponents. What's the exponent on this first one? 2 times 2x, 4x. The exponent here, minus 1. So what's x? Minus 1/4. Divide both sides by 4. Okay, so that's a complicated one that you would make the bases the same. It's really as hard as they get if they work nice. Okay, this one, can we write 100 as a base 3? No. Right away, if you think of 100 as 2 times 50, that didn't have a 3 in it. Had a 2, so it's not going to work. So what do you do to both sides? Which log? We'll cancel out the 3. Log base 3. We don't work that out, although you could do a guess if you wanted to. These cancel, so minus x equals log base 3 of 100. What do we do with that minus to get the answer? Multiply both sides by negative, change the signs of both sides, so the answer would be x equals minus log base 3 of 100. And you just leave it like that. Just like if you had a cube root of 20, it doesn't work nice, you just leave it as cube root of 20 without a calculator.
So in the final one,
You would just leave it like that, yeah. But knowing that you could actually find the answer if you wanted to, either in a calculator or by guessing. What about this one? E's scare people, but I'm telling you they're the easier ones because you don't actually need to think about the powers of E. They just either have an E or they don't. So the base is already the same on both sides. So 3x plus 1 equals 2. And we just solve it. So the base was the same. They already matched. This one, can you write 6 as a base E? No, nothing unless it already has an E. Right, so if you see something like this, what log would we take of both sides? Log base E, which we write as ln. So ln, these cancel. Ln 6 is just a number, we just leave it like that. X equals ln 6 minus 1. Be careful that if you were putting that in a calculator, what would you not want to do? What would be wrong to plug in? What do you think some people would do by mistake? Right, and do ln 5. If ln 6 is a number, and then you want to subtract 1 from that number, that's different than ln 5. So be careful of that. This is ln 6 as a number, and then subtract 1. Okay, be careful that you don't put ln 5. Yeah.
Are we able to use calculator?
No. But like I said, in the calculus course, they'll expect you to do it on your homework. Yeah. And if you take math and anything else after first year, you use a calculator. So it's good to know that you can do that. Yeah. You just wouldn't want to write this as ln 5 anyway. Okay, so now that's solving for x with exponentials. So that was 2 types of exponentials. Either you match the bases or you don't. If they match, you compare the exponents. If they don't, you take the log of both sides. So those are the 2. The next solve for x if the equation contains a log. So if it has a log in it to start, the ones we just saw were not, they didn't have any logs in them to start, we put a log in. So now the type is if it already has a log. So there's still two types. One, say both sides of the equal sign have a log. And we compare the arguments. So for example, if I had log x equals log of 2x plus 1, there's a log on both sides. So to solve this, we say, well, the log already matches. We just need to make the arguments equal. And we solve that. Yeah, base 10. Which you don't even need if the log is the same on both sides. Now, when we were solving equations that had a square root, what did I say you always had to do, which you didn't have to do for anything else? Check your answer. Logs are the same as square roots. You can only plug in positive numbers. Is this the answer? Can you plug -1 in here? No. If you did that, you get error. Just like if I did square root of a negative number, -2, it's going to say error, because you can't take a square root of a negative. Log of -1, it's going to say error. Same thing, because you can't plug a negative into a log or a square root. The domains are the same. So we would say no solution. That was the only possibility, and it's not going to work. Why is it no solution? If you were to check your answer, log of -1 is undefined. When you have a calculator, did you see it said error 2? There's different errors on a calculator. Error 2 means that it's not in the domain. Now that's actually what it means. You put something that isn't possible. What would be like divided by 0? Same kind of error. You can't divide by 0. That's a domain error. Error 2. Okay. So some of these would work. I just wanted to make sure that you know that if it starts with a log in it, you have to check your answer, just like if it starts with a square root. Both of those, you have to check your answer. Okay, so check answers for square roots and logs. All right, so the second type is if we have a log on one side and, say, a number on the other side of the equal sign. So, for example, if I said log of x plus 1 equals 2. So it doesn't have a log on both sides. So just like if we had the last type, exponential, we had to put a log on both sides. What do you think you have to do to both sides here? Raise it to whatever base the log is. So this is what base is this one? 10. So you could write that in there, but it wasn't there originally, but you could write it in to say that's a base 10. How do you cancel out a log base 10? You use a 10. So you would say 10, and it's an exponent. You raise it up as the exponent, equals 10 to the 2. So you do that on both sides. these cancel, so you get x plus 1 equals 10 squared is what? 100. Now, this had a log in the original question. Can you plug 99 in there and not get a negative? Yeah, so it's fine. But you should always look. If it says check your answer, you'd have to actually write it down and show. But if it doesn't say, just kind of look up. So, you know, if you wanted to check, say log base 10 of 99 plus 1. Right, but what you're really checking for is if, when you plug it in, it's not negative. Okay, so what we'll do next class, we're going to take these two types, do a couple more examples, and then add in a couple rules of logs to make it a bit harder. And we'll finish logs next class.